Hello, can you hear me?
Yes.
How are you guys doing? Good.
We
We
can
can
hear
hear you. Good.
Okay, excellent, excellent. Um, Today I'm still grading your work. I haven't finished the classwork one. I will probably finish it by this weekend. Then I'll start grading classwork two. Now, you know already that classwork three, you have to bring it to the classroom. I explained in the class what you are required to do. I also updated it on the Canvas where explained step by step what you are required to do for classwork three. I need it done, and the goal there is to make sure that if I give you a question on that system and leaf plot, you can be able to handle it. So be prepared to prove your work on Tuesday next week, okay? On that. Now, today we move into a new chapter. Don't forget, the same link you used to log in today, that will be the link you'll be using throughout the semester on Thursdays to join the class. Okay? No other link. That is the only link we'll be using. So let me introduce you to what we have today. Before I do that, give me a few minutes to take down some of these names that I'm seeing on the screen. Random. I didn't see Randall here. Wedlock. I see Wedlock. I see Martin. I see Martin here. Okay. Expansion. Some of them I don't even see them. See? Erwin, Savannah Erwin. What is it that I cannot even? Okay. We have Cookski. Oh, got it. Hannah Hannah. Why is it?
It's
I think
it's Hannah Washington. I'm sorry.
Washington. Okay, okay,
I have
okay,
no idea how to change my name on here.
okay, okay. I see. Because I was
Thank
looking
you.
for it. I was looking for it here. Right. Okay. Yep. This one here. And I got St. Jean. Got St. Jean here. Okay. I got everybody now. June. Yep, got it. Here. All right. So we will be looking at chapter 3, which is on data description. Remember, I explained that, and I keep referring to it. Can you see the screen? What we have on the screen is on statistical methods. Can you see it on the screen?
Yes.
Oh, good, excellent. So we'll be looking at data description now. In statistics, we collect data, we analyze data, and we interpret. So today we'll be focusing on the measures, how to describe data. There are three ways, actually four we can be looking at. Measures of central tendency, measures of variation, and measures of position. Then, of course, we'll take a look at the exploratory data analysis. Now, today we focus mainly on measure of central tendency. Now, these measures tell us the center point. In fact, they describe the center point of a data set. Even though we're focusing on that today, I will introduce the rest of them so that you can have an idea of what they are talking about. So the measure of central tendency describes the center point, and we have four of them we're using here. First one is the mean, or what we call the average, the median, and the mode. Then we have the mid-range. Mid-range is just a rough estimate of the median. Now, the median mean is the average. We can say the average age of students enrolled in a college in a particular semester, or the average price of gas in Baltimore, things like that. That's what the mean is talking about. Now, median is the middle value. Last class, I explained that the income is usually right skewed. So because of that, we cannot use the mean as a reliable measure for describing the income of a state or city because income is right skewed. So for that, you can use the median. So if you use mean we can overstate the income because I know we have millionaires living in Maryland, for example. If you get their income and the income of somebody who is making a, uh, depending on the food stamp and welfare benefit, and if you add all them and divide them by the number of items, it will give you a very high income, and you will be thinking that somebody who live in Maryland is rich because the mean is always affected by extreme value, like that millionaire income. So because of that, we use the median to measure income. It's like anything that income, things that are most are skewed to the right side usually use the median. So what is the median anyway? The value, the middle value of a data set. Value middle. So, for example, if we say that the income, the median income of college professors in 2018 is $65,000 per year, it means that half of them make that amount or less, and the other half make more than that amount or more. Now, mode simply means the data value that have the highest frequency. And we use mode to, as a metric for measuring the popularity, a measure of popularity that reflects central tendency. Things like the most popular political candidate. Well, in last year election, definitely Trump was the most popular because more votes went to him than Kamala Harris. But the one before that, the election they had before that, it was Biden and Kamala Harris who were the most popular because more votes went for Biden and Kamala Harris, and they won. So they won that one because they are most popular. That's the mode for that time. Then last year's time is more Trump becomes the mode. We can also say the most popular stock. If you look at the stock market now, it's like basically hyper. And among the most popular stock, I think the most popular now is the Nvidia. I think it's Nvidia. It's an AI stock, a company that produces chips for AI. One of the most popular stock now because of this era that we are in. We are in and the era of AI boom. The most preferred washing machine, things like that, reflect the mode. Now, when let me put it this way. When we have data set have more than we have one mode, have only one mode, we say that it is unimodal. You can see it on the screen. It has one mode, called a unimodal. Okay. When it has two modes, we say it is bimodal. And we have more than one mode, we call it I would say multimodal. Now, the mid-range, like I said, is the rough estimate of the middle value. So this is the formula for finding mid-range. And all these things that I mentioned, they have formula where we used to calculate them. Like the mean, you can see the X bar, we use this symbol here, mu, to represent the population mean. We use X bar to represent the sample mean in statistics. So this is the formula we use for the X bar is sum of X times N. Then for the this symbol here is a symbol that we call it sum of. I think it's a Greek symbol. So sum of X values. So but the good news is that we are now in the age of technology. So there's technologies we can use to get these answers as well. Not AI. I'm talking about, when I say technology, I mean Excel or scientific calculators. Okay. AI will not using AI to solve them will not give you any credit. So I recommend that you might use AI to study, fine, but don't use it to complete assignment because it will not give you credit. Every assignment here requires proof. Okay. Now, this gives you a background on the measure of variation, central tendency. So we have formulas we use to calculate them. But like I say, we are using the technology and the formula. Whichever one you use, as long as you can prove it, you are good to go. I'm going to show you how we can get them so that at least when you see them, you know what you're talking about. Now, let's look at measure of variation. Variation, unlike the measure of central tendency, They describe how far, how the individual data sets have strayed from the mean. And I'll give you an example with a real, with a real life situation. I'm going to use a real life situation to give you an example. Suppose that that road to Morgan, I think is called uh, Perrin Parkway. Perrin Parkway. Suppose that the speed limit, the average the speed limit there is 45 miles per hour. And then that is average speed required. But somebody is going 50 miles an hour. So that means that person has strayed from the average speed by 5 miles per hour. I mean, if the speed limit is 45 miles per hour and you're going 50, you are still good. No cop will stop you because of that. Only five, you know, miles per hour difference. But if you are going 60 miles, that means you are deviated. That means by almost like 15 miles per hour higher. Or if you're going 25 miles per hour in that same road, some cops can stop you for going too slow as well. So anyway, so if that deviation, that's what we're talking about. We're talking about measure of variation. And I'll give you another example. I think the blood sugar level, blood pressure, I think it should be this diastolic. I don't know what they call it. They use some technical terms, but there's a one that is like 120 is good, normal. If it's 140, that's a problem. Or if it is 90 something, that's a problem. So that's give you an idea, a picture of what we are talking about when we say measures of variation. If the variation is too much, we become concerned. So the measures we're talking about that we use to calculate this, the metric, well, I'll call it the statistic. We use to calculate this measure. Let me put it this way. The measures of variation include the range. I'm going to highlight it for you. Variance, standard deviation, and the coefficient of variation. So, range is the easiest one to calculate, and just the maximum data entry minus the minimum data entries. Variance has a more complicated formula, but even at that, we just need it to get this standard deviation, which is the one we normally use to make inferences under the measures of variation. There's a formula we use for them. We will focusing more on using technology like Excel and scientific calculator to get these answers, mainly on Excel, because Excel can deal with a large amount of data. So it's the area you familiarize yourself with how to use Excel to get these answers, the better for you, especially in this class. Okay. Any question in what I've said before we continue? Any question? Excellent, excellent. So let us proceed with the coefficient of variation. Now, the coefficient of variation represents the ratio of the standard deviation divided by the mean. And we use it for comparing the degree of variation from one data series to another, even if it means even if the means are drastically different. Those in stock markets use it a lot. They can use it to compare how the individual stock varies in comparison with the market indexes like S&P 500 and so on and so forth. Now, we can also use it to compare the standard of living or the cost of living in two different cities, like New York and Baltimore. Now, I've shown you all this. Now, this is the computational formula for variance and standard deviation. If you want, I can show you how to use some of these formulas when we meet in the class physically. But for most of the calculations, we use Excel. And remember, even Excel, to get credit, you have to actually do the calculations. I will show you how I verify my answers and verify that you did the job and that you didn't, you follow all the steps. Okay. Now for the variance is sum of x squared. Excuse me. Let me make sure I see it. First of all, this is the symbol for population variance, delta square. This is the symbol for sample variance. This is the formula for finding the range, maximum data entry minus minimum data entry. And this is the formula for finding the variance, sum of x squared minus sum of x squared over n divided by the n minus 1. Now, you guys are lucky in your own days, the technology is everywhere. In my day, we use pen and pencil to do all this writing and calculations. We still do it today. So you're still going to be doing that in this class. In some cases, but majority of them, you'll be using Excel. Okay. Now, for the coefficient of variation, we're using a standard deviation divided by um, uh, mean times 100%. Like I said, we can use it to compare two different things. Now, let us begin. We start with the ungrouped data. It says that an experiment was conducted to measure the effectiveness of a new procedure for pruning grapes. Each of the 13 workers sampled was assigned the task of pruning an acre of grape. The productivity measured in worker hour per acre is recorded here. You can see the 4.4 hours, that is the output. 4.4, 4.9, all the way to the last one. And this is for 13 workers. It says, calculate the following: the mean, median, mode, mid-range, and explain our result. Now, the best way is to summarize those things in a table form, which I did here. See, all table form. Then you can now be able to calculate the mean, median, mode, and mid-range. So I put them in a tabular form. Now, how many of them do we have? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 of them, you can see that I give them a serial number 13. So our n is 13. Then this is the productivity. Now, to find the mean, I'm going to get the formula down here so you can see how we use it. This is the form. Oh, I didn't write it here. Okay. Oh, I did right here. Mean. I'm going to copy it right here and bring it down. Write it. Okay, down here. So sum of x. Let me see if I can make it bigger so you can see it better. Okay. See, sum of x for n. And for us, the sum of x is the mean to add all these numbers. Each of these is represented by x. This one, x1, x2, x3, x4. So this is x. We add all this, get 59.3. So it says sum of x per n. So because this section will not allow us to write these symbols, I'm gonna get it put it in take it to a new workbook where we can put it in. But let me write this down. N is 13 workers, right? And sum of x, okay, if you add the total is 59.3. So taking you to that other workbook so you can calculate the mean. Workbook is right here. Okay. We are not at the workbook. So that they bring this down. The mean I'm gonna make this bigger so we guys can see it clearly. The mean which we represent with x bar x bar okay equals I have the sum of x over n. This is for ungrouped data. Oh, excuse me, sorry. So you keep doing that. Okay. So I'm gonna make it a little bit bigger, probably 20. Make it 20. So now we have our from the other workbook that n is 13 and the sum is 59.3. So we'll go and put it in the formula to get our mean. So the mean will now become, okay, 59.3 over n. N is 13. Okay. This is new equal. So 59.3 over 13. Let's go and put this on the calculator. We got I have my calculator decimals. What is my calculator? Okay, I'm sure I opened it. Okay, I'm gonna try this way. Yep, right here. It's right here. Opened it. So let me share it with you. Calculator. So it says 59.3 divided by 13. 4.56. 4.56. So 4.56, let's go and put it on the workbook and then copy it to the main workbook. Okay, 4.56. I'm gonna copy this, go to the main workbook and paste it there so that we can interpret it. So this is what I mean right there. Okay, 4.56. So what does this mean? So again, remember, you add all this, can't get the count, put them in this formula to get the answer of 4.56. It means that the average amount of time taken by the workers to prune an acre of grape using this new procedure is 4.56 hours. Does anybody have a question? Any question? Excellent, excellent. No question. Good. Now, for the median, the first thing we do is to put them in numbers in order because they want us to find the median as well. You can see this. Find the median. See, find the median. So put them in order and pick the number from at the middle. So see smallest to largest. And there are 13 of them. So 1, 2, 3, 4, 5, 6. So this is what we highlight. 1, 2, 3, 4, 5. So the median number at the middle is 4.5. All right, 4.5, the median. So you can see that the interpretation says half of the workers can prune grapes or can prune an acre of grape using the new procedure in 4.5 hours or less, while the other half can do the same job in 4.5 hours or more. So that's how we get the median. Now this is for small data set, and for large data set, this cannot work. And I just wanted to let you know that. Then for the mode, it's something you put them in order and pick the one that occurred most frequently. Now look at this one. 4.2, we have 4.4 occurring 3 times. I'm going to highlight it. I've got 4.8 also occurring 3 times. These two of them have, so it has 2 modes. So the mode will be 4.4 and 4.8. See? So that means, what does this mean? It means that these were the most frequently occurring productivity rates among the workers when pruning grapes. And what does it suggest? It suggests that these rates are the common benchmark for this task. Any question, guys? Hello, guys. Are you there? Can you hear me?
Hello,
Yes.
Professor. Hello.
Yeah, can you hear me?
Yeah, I
Yes.
can hear. I just had a question. Will this meeting be recorded?
It is being recorded, yes.
Okay, cool. Thank you.
Okay. So now, next is the mid-range. Mid-range is the rough estimate of the middle. The maximum value divided plus the minimum value divided by 2, which will be minimum amount of value there is 4.2, maximum is 4.9. So it's gonna be mid-range will be 4.9, 4.2 plus 4.9 divided by 2. That gives you the mid-range. I'll write this down so that we can get this from calculator. 4.2 plus 4.9 plus 2. Okay. So I'll take it to the calculator. We got 4.2 plus 4.9 divided by 2. Give me 4.55. 4.55. So we got 4.55 as the mid-range. 4.55, which is a close estimate of the median. Remember that our median is 4.5. And we get the mid-range 4.55. See? Remember, I say mid-range is a rough estimate of the middle. Now, the median we had before, numbers are 13. That means they are odd number distribution. For that case, you can easily pick the median from the middle. But sometimes you have an even number distribution like this one here to find the median. So there's no single number in the middle. In that case, what you're going to use is the two numbers that are in the middle. You get the average to get the median. For example, here it says, find the median of the weights listed below. Okay. First thing to arrange them in order. In that case, say I think it's already arranged. Yeah, it's already arranged. So the median now becomes these two numbers at the middle, the average. So it's gonna be 235. Okay. Plus 268. Okay. Divided by 2. I'll give you the mid-range. Okay, I'm gonna write this down. 235. So I'll give you the median, not the mid-range, median. 235 plus 268 divided by 2. I'm gonna put this right here for us to see. 235 plus 268. Okay, divided by 2. I got 251.5. 251.5, yes. 251. So, and that's it. Now, that's how to find measures of central tendency using formulas. Like I explained, most of the time you'll be using Excel or scientific calculator to do it. So I'm going to show you how to do this in Excel. I'm going to include the measures of variation. So let me use one data set that includes measures of variation. And then I will require you to calculate. Let me use that data set. I'm going to put it here. It says the same data set as we have. Experiment for pruning grapes. But in addition to that, or maybe I can just let me use a different question. Let's use this one here. It says that the European, 1 minute. Yeah, right here. The European auto sales for a period of 6 years is shown here. These are in billions of dollars. Calculate the following: the range of the data set, the sample variance, the sample standard deviation. Let me add this. The mean, the median, and mode, mid-range. Add all this since you're going to use technology. Okay. So first thing, of course, that is to put this in the Excel. Now you can use the formula. I showed you the formula for variance here already. I think I showed it somewhere. Yep. Somewhere at the back, I believe. It's at the back. Yeah, I think I said it. Yep. This is the formula right here. And if you want, I can explain it and do an example when we meet in class physically. However, to save time and to make you understand the concept even faster, We're going to use the technology to solve this. Okay. So the first thing is to put these numbers in Excel, and then we can get our data set. I mean, our answers. Excel make it faster, and we can still practice the formula methods when it is required. Okay. All right, let's do it. So by entering the data set in Excel, be very careful, because if you make mistake, all your answers will be wrong. So be very careful. So I'm going to put this here. Write the numbers down: 11.2, 11.9, 12.0, 12.8, 13.4, 14.3. Okay. Let me go and put it 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm going to take it to Excel so you can get it. And I will show you how to arrange it there so that your data will be easy to understand. Your work will be not have any mistakes. So let me put it right there. This is Excel. Now let me ask you, all of you, can you see the screen, the Excel screen? Can you see it, guys?
Yes.
Oh, good. So let me put the numbers in. 11.2, 11.9, 12.0, 12.8, 13.4. We got 14.3. And the question wants us to find what again? It says here, the range, sample variance, sample standard deviation, sample mean. So you got to type those things in. Okay. They want to find the range. Range, yep. Oh, that's my mistake. Range. Okay. They want you to find the let me write this down so I can just type it in. They want the variance. They want the standard deviation. They want the mean, a median, and mode. Okay. Let me make this let me increase this to 11.9, and like 11.9 again. Yeah. Okay. You have 12.0. Oh, okay, it's for 6 years. 7.9. 1, 2, 3, 4, 5, 6. 13 point. Okay. Anyway, we got there. So you have sample variance. Sample standard deviation. Then mean, median, mode. Then what else? Mid-range, right? Mid-range. Okay. Now, all you have to do now is to now do the calculation, and you are be good to go. Range. Okay, I put them at the wrong spot. Let me put them at the right split. Right here, so that I can remove these ones. Okay. Okay, good. Range, as you know from the can see from the formula, is the maximum data entry minus minimum data entry. That's the largest minus the smallest. That's what it means. Okay. So now that means equal range. Just type in max. Double click. Highlight all of them. Close the parentheses. Minus the minimum. Mean. It will pop out here. Double click. Highlight all. Then close the parentheses. So max minus mean. When you do type of max, remember to put equal sign first. Max, it will pop out. Click it. Highlight the numbers. Close the parentheses. Put the minus sign. Then type mean, which is the minimum value. Highlight it. Then press the enter key. That'll give you the range. 3.1. And you can see it right here in the paper. I wrote here that the interpretation says here that the auto sales data, because I got 3.1, the auto sales data varied by a range of $3.1 billion over the 6 years. See, which means that the lowest sales figure recorded during this period is 11.2 billion. That's how you go about interpreting this. Now, next one is that we need to calculate is the sample variance. As you can see, the formula is a little bit complicated. It might take you some minutes to get all these calculations and then put them in the formula, which is this formula here. And again, once again, I can explain to you more when we see the class. Put in this formula then to get the answer, and then get the square root of that. So, but Excel make it easy for us. If you learn it, believe me, you're gonna solve a lot of headache. That's why I'm emphasizing on it this class. So for this, we use simple formula equal VAR dot S. Dot S means for sample. Once you put it that way, it will pop out here. Double click and highlight it to the last digit. Press the enter key. That's a variance right there. And the standard deviation is simply put equal sign, type STDEV dot S. Dot S means that it is for sample. If you put dot P, it means for population. Double click, then highlight all, press the enter key. I'll give you the standard deviation right there. And then mean, I showed you how to use formula to get the mean. And I'm going to show you how to get it with Excel. Just type equal, type average, that's for the mean. Pops out, double click on it, highlight all numbers, press enter key. That'll give you the mean right there, 2.6. Now compare this to how long it took us to get the other one. You can now see the difference. Median and mode, sometimes the answer we get for them in Excel might be a little bit different from what we have in calculation manually. Like this one, you have, let's see what you have for median. Median, MED pops out, double click, highlight this, press the enter key, 12.4. And then, in the manually, if you want to do this manually, you have to put them in order. And then you can see, well, let me put them in order here, highlight it, and choose, I think they call it sort. Say sort and filter. Choose from sort smallest to largest. So it's on the smallest to largest already. And since it doesn't have it's an even numbered, that means a median will be equal if we're doing it manually. These are the two numbers at the middle. I'm going to highlight it right here. So you can see that the answer will be a little bit different from what we have from Excel. 12 plus 12.8 divided by 2. That's how you do it if it is an even number distribution and two numbers are in the middle. 12.4. Oh, okay. It was correct. You gave us 12.4. Sometimes it happens that way. And the mode equals MOD. It pops out. And then highlight the numbers. Press the enter key. Yeah. He said that I entered an invalid argument. Let me see where he said that. Okay. Okay, say MOD equal MOD. Okay, I used something different. See the mode right here. Mode. It's gonna be a single mode because it doesn't have I don't really see the mode. No number repeated itself, but let's use this single one. mod.sng sngl pops out, and then I highlight all this, enter key, not available. You know why? Because there's no mode here, no number repeated itself here, so it has no mode. The mid-range is the maximum data value. Sorry, minimum plus the maximum divided by 2. The largest value plus the smallest value divided by 2, which means minimum MIN pops out. Okay, I want to make it put it in parentheses, 2 parentheses. Okay, minimum MIN, it pops out, double click, highlights the holding, close it, plus maximum max pops out, double click, highlight all of it, close it. Now, because if you look at the beginning, you have 2 opening parentheses, so you gotta close it twice. Up, okay. I think this is 1, 2, 3, 4. Okay, we have 4 opening parentheses. 1, 2, 3. I've got 2. Okay, close twice. Yep, twice. So minimum plus maximum divided by 2. Give us the mid-range. 12.75, which is a close estimate. You can look at the median, 12.4, and mid-range is 12.75. So it's a close estimate of the median. Now, any question before we round up? Any question? Hello, can you hear me, guys? Any question? Hope you are all there.
No, we can hear you. I ain't got no question though.
Yes, sir. You say you have a question?
No, I was saying I can hear you, but I didn't have a question.
Okay. All right. So now remember to finish your classwork 3 and bring it to class on Tuesday, and continue with your other homework. And I will see you guys on Tuesday at the campus. Okay? You guys have a nice weekend. I'll see you on Tuesday.
Hi, Professor.
Thank you.
So I had a question. So what exactly is due? I know. So is homework number 2? Is that due this weekend?
So to answer your question, I think that your question have already been answered, but I'm gonna show you where I have the answer for you. Give me 1 minute.
Because the last assignment you assigned in class, it was last class, you said to look at the video. I recently just did that like yesterday. I was trying to figure out what else should I be.
Is it the one you're asking about?
Yeah, is that what is that was that?
That one is not actually. I wrote it is due to yesterday, but in the class I explained that I want to do it and bring it on Tuesday next week. So
Okay, all right,
it's
that
not
makes
past
sense.
due. Yeah. The other one
Okay.
I do is the homework. The one you do in Pearson. I hope you are working on that.
Okay, so do we have something in Pearson that's due this week? Because I'm seeing some for October. I was trying to see if we had.
You should see my announcement.
Okay.
For this week, you see the assignment that are due this week.
Okay, all right, that's cool.
Yeah.
All
So
right. Thank you so much, Professor.
Oh, you're welcome. So that, guys, if you have a question, I don't respond to chat. Ask me. I'm right here now. Ask me if you have a question. Does you have a question? Anybody else have a question for me?
No, I was saying, did you take attendance today?
Oh, what's your name?
Jonathan.
What's the last name?
Theano, Theano.
Oh, Jonathan, right?
Yeah.
Yeah, I have it. I have you now.
Okay. Appreciate you.
Okay. All right, guys. See you
Did
guys.
you? I
Huh?
have a question too.
Yes,
Sorry.
ma'am. Yes, ma'am.
I don't think you wrote my name down for attendance either, but I also have another question regarding homework that's due Tuesday.
What's your last name?
Smith,
Tania?
Tanaya.
Tania. Oh, yeah, I got you now. Yep. Then what's the next question?
Okay. For the homework that's due Tuesday, when you were saying to write down the question 3 times, do we make up our own set of numbers? Do we write down the same
The same
numbers?
question because I'm working on that question. Like, I want you to do it. Why I said 3 times is when you do things over and over. If you don't understand it the first time, the second time it will absorb. Third time it will absorb. So that when I ask you, when we bring in the class, I may not ask you any further question. But if I decide to, it's okay. Let me give you a test on this one. Do this for me in the class before we go. So you'll be able to handle it. You see what I mean?
Yeah.
So it's the
Okay.
same question, the same work. Just want you to repeat it.
Okay.
Then bring it up on paper.
Okay. Thank you.
Welcome. All right, guys.
I have a question.
Yes, sir.
So when you say that we were supposed to bring it in class, it also says to upload it in Canvas. Are we
No,
supposed to
don't upload.
upload that?
Don't upload. I don't grade the upload. The one sir, I want you to understand one thing, sir. This class is based on evidence and proof. That's how you get a grade. So the best thing to when I provide say that I want to see that you did it. Then if I decide to ask you a question, suppose I decide to ask you a question then you'll be able to do it, follow the same thing you did on paper, and use it to finish the one I gave you. You see what I mean? Hello?
Yes.
Yeah.
Yes.
So that's what I'm saying. If you do it only once on paper and you grab this concept, then you don't have to do it twice or three times. The idea behind telling you to do it 2 or 3 times is just to make sure that you grab the concept. Okay?
Okay. All right. Thank you.
You're welcome. You have a nice day, guys. Have a nice weekend, I would say.
Thank you. Have a good weekend as well.
Yeah. Me too. Okay, it's the house. Yeah, I used to click here to bring.